Perfect squares. You're able to achieve a perfect square by taking a number times itself, like 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. The list doesn't stop at 13 times 13. 14 times 14 would be 196, 15 times 15, 225, and it just keeps going. So a couple things to look for here. When we're factoring binomials, we sometimes need to factor out a numerical value in front, and we'll see that down below. But two things. If we are doing difference of squares, the numerical values that are in these two places have to be perfect squares. So we have to break them down equally, like 9 breaks into 3 and 3, and 4 breaks into 2 and 2. Also, if we happen to have a variable, the exponent or the degree has to be divisible by 2. So 2 is divisible by 2. Sometimes when I say that, students don't really understand. So if this number was 4, and you ask yourself, is it divisible by 2? Well, divide it by 2. If you get a whole number, then it's divisible by 2. If this value was 3, and I said, is it divisible by 2? The answer is no. When you divide by 2, you don't end up with a nice, even whole number. Also, the sign in between the front and the back has to be subtraction. So let's get started. 9 breaks into 3 and 3. 4 breaks into 2 and 2. The exponent on the variable is divisible by 2. So when I divide it by 2, I get a, and I have subtraction. So I'm showing my work right now. I'm going to now break this into two groups. The 3's and the a's come from the front. The 2 comes from the back. 1 is positive and 1 is negative. It doesn't matter which one goes in front, which one goes in back. 2 is tricky. 36 and 49 would be on this list. 1, 2, 3, 4, 5, 6. So this breaks into 6 and 6 and 7 and 7. And the exponent on the variable is divisible by 2, but because we do not have subtraction between the two groups, this is not factorable. Let's go on to number 3. Now number 3 is an example where I see an 8 and I see 50, and then I come up to the top and I ask myself, well, what am I going to do? 8 is not on this list and 50 is not on this list. What do we do? So then we're going to choose the smaller of the two numbers. In this case, it's 8. And I want to write down all the numbers that nicely divide into 8. 1, 8, 2, and 4. And if you're confused how I'm able to get those, take 8 divided by 2. Since it's an even number, we're able to get a nice whole number. So 2 and 4 go in. We know 1 and 8 go in. Now, how do I know 3 and 5, 6 and 7 don't work? Well, just because of number sense, I know that. But if you didn't know, you can take 8 divided by 7. It's not a whole number. Divided by 6, not a whole number. Divided by 5 and 3. We can see that none of those numbers divide to give us a nice whole number. So what am I going to do with this list? I always start with the larger number, which happens to be 8, and I'm going to take 50 and divide it by that number. If I get a nice whole number, that's what I'm going to divide out, or I'm going to factor out that value. 8 didn't work. Let's try 4. 50 divided by 4. Nope. Let's try 2. We do want to factor out the largest number. Oh, 2 works. Okay, so that tells me this is the number I'm going to factor out. 8 divided by 2 is 4. Bring down the f squared and the subtraction. 50 divided by 2 is 25. Now I'll come back to this outside value later, but look at 4 is on the list up above, and so is 25. 2, 2, 5, 5. This is divisible by 2, and I have subtraction. So I have 2 parentheses. Don't forget about the 2 up front. And now the 2's and the f's come from front. The 5 comes from the back. 1 is positive and 1 is negative. Let's go down to number 4. Again, 128 and 50, not on the list. So I'm going to write down all the numbers that divide into 50. 1 and 50. I know 5 goes in 10 times, and 2 and 25. Always starting with the largest one. So I'm going to take 50 and see does it divide into 128 nicely. Let's check. Nope. 128 divided by 10. I should divide it by 25. That'd be the next largest. No. 128 divided by 10 does not work. 128 divided by 5 doesn't work. 128 divided by 2. It does work. 2 is the largest number on the list that works. So I'm going to divide out a 2. 128 divided by 2 is 64, and 50 divided by 2 is 25. And now 64 and 25 are both on the list. This breaks into 8 times 8. 5 times 5 and 8 times 8 because that's divisible by 2. Now, what is a common mistake I often see with this problem? I often see students taking the variables and putting them in front. The only thing in front in this expression is the 8. And back will be the 5h and 5h. One's positive, one's negative. This problem is done. Let's look at this bonus problem. 16 and 9 are both on the list, 4 and 4, 3 and 3. Both exponents are divisible by 2, and I have subtraction. So if I take this number, this exponent, and divide it by 2, I get x to the third and x to the third. Divide 4 by 2, I get 2 and 2. These have to add up to the exponent 4, and 3 have to add up to 6. So 2 parentheses, 4's and x's come from the front, and 3's and y's come from the back. One is positive, and one is negative.